My name is Mateusz Dorobek, and today I would like to tell you about my poster on Jazz chords generation. In this project I've used two types of neural networks. First of them is embedding neural network, which I used to encode symbolical representation of chords into numerical form. And the other one was a recurrent neural network, which I used to generate sequences of chords. Let me show you how do I use all these networks in the whole system. The pipeline was like this. First I downloaded the data from the internet. These were the songs containing chord symbols, real jazz songs. I extracted the chords and put it to train embedding. Embedding is kind of network that can generate numerical representation of token like words, chord symbols, any tokens that occurs in some kind of sequences. And I won't focus on how they exactly work, but I will show you an example how it works in this specific area of jazz chords. So I've used embedding to generate numerical representation for each chord in a song, and this created a dataset which I used to train generative model of recurrent neural network, which was then used to generate samples, new samples based on some kind of input. This process could be supervised by a user or be totally random. After generating the chord sequence in embedded space, in numerical space, I used embedding to transform it back to the symbolical representation, which are the chords, which can be played by a musician on instruments like a piano or a guitar. And embedding as a neural network has very interesting properties, and its main application is in words of a spoken language. I've used it in this area because I think chords, the same as words, make both long and short dependencies in its sequences, and I think that using embeddings can extract this property and work as well as with words. So right now I will show you how some of my chord embeddings represented in 3D space shows the properties between the chords. This is one of the embeddings, Word2Vec with CBOW of size 13. I've used PCA reduction algorithm to show it you here on 3D space. This is a TensorFlow tool embedding projector that will show us really interesting interactive visualization of this embedding. What we can see right now on the screen are the chords in their numerical representation reduced by a PCA algorithm in a 3D space. The colors are the class of the chords, and right now I will show you one certain type of chord class. Let it be okay, half diminished chord. And what I wanted to show you is, okay, give me a second. Okay, maybe I'll show you a different kind of chord. This is a major 7 sharp 11 chord. As you can see, these chords occurs in this space in this circular pattern, and for every musician that know circle of fifth, which is a basic musical structure, you can see this structure here. This chord occurs in a certain order. This is the order of musical circle of fifths, and this order occurs here only because some certain properties between these chords occurs in real music. This is not hard-coded, this is not pre-prepared. This occurs only because the structure of music shows us. And this basic basic musical form of circle of fifths is visible here, even in this non-usual type of chords. Let's switch to different embedding. Fast text. This is another embedding that use n-grams, which is a technique of using parts of the token, which in chords, of course, have its own sense of taking only a type or extension of a chord. And here I can show you the same chord. Okay, and here we can see that this pattern also occurs. So it's not only a strange behavior of some kind of embedding, which was a word2vec, and this also shows that these important properties in chords occurs in different embeddings too. Another one, this is word2vec with a skipgram architecture with a bigger size of 70. And here I will show you how group of similar chords are close to each other. This is a chord B flat, and this is its neighbor. These chords are very close to each other for one reason. They are very similar, and they occurs in music very often together as a neighbors. And this is visualization how this property occurs in embedding. So if you are using numerical representation of a chord very close in that embedded space, there are chords that are similar that you can use as a substitution. So this embedding gives us this property of high variety of chords that you can use. It's not tokenized as in hot encoder, where there is one token and there is a completely other with different index, and we cannot compare them. Using embeddings is a very good technique because it allows you to use different variations of certain chord. You can diverge through a space that is continuous, not discrete, and you have this property of distance, which tells you how similar are the tokens that are in this space. So for chords and words, using bag of words representation or some kind of hot encodings it's not anymore used. So if you're trying to extract features from these tokens, definitely focus on embeddings and new approaches that are developing right now as transformers and GPT models. Here I'm using very simple models that are the most basic implementations from the early stages of NLP, and as we can see, they already give pretty good results. So you can only think about what will more complex models give. That's it for this short presentation. If you are looking for more information about this project and other details connected with it, try the QR code on my poster. It will bring you on my site, and here, of course, my poster, system diagram, and demo video where I use this algorithm to generate music. And if you like to hear how it sounds, how sounds the music generated by artificial intelligence, definitely try it out. So thank you. I hope you liked it, and I hope to see you soon. Goodbye.